The point of this lab was to look at an object that was moving at constant speed in the same direction. This would mean that the object was moving at constant velocity. We look at Newton's second law when the F net is equal to 0. This means that the total number of pushes and pulls cancel each other out and there are no forces acting on the system. Therefore, this would mean that the final velocity would be equal to the initial velocity. When there are no forces acting on an object, Newton's first law comes in by stating that an object that is in motion will stay in motion when no forces act on it. The object that I observed was a pen rolling across a table. The pen was considered the system. The data was analyzed using the software tracker. I used the axis of positive x since the pen was rolling in the right direction. The origin was identified as where the pen started. The mass of the pen was 0.0151 kilograms. The point mass was taken in the middle of the red tip of the pen for each frame. The calibration stick was the diameter of the top of the pen, which was 0.01 meters. I only looked at the middle part of my video to try to get where the pen was moving at a constant speed. The graph that was created using Tracker shows that the object was pretty close to moving at a constant velocity. The line that is basically straight shows this. The reason that the slope is going in the positive direction goes back to my decision on having the pen move in the positive x direction. Tracker also gave me the individual position and time points that helped me determine the initial velocity. These right here are the position points, and these are the time points. The initial velocity was calculated by taking the position 2 minus position 1 over time 2 minus time 1. When this calculation is done, it gave me my initial velocity of 0.21 meters per second. Now you are able to see the model that I created. The important things for this code were identifying the initial velocity, which is right here, and understanding that there were no forces acting on the system. The initial velocity that was calculated will be used as the constant velocity throughout the model, and this is these equations that I showed here. The F net vector was coded to 0, 0, 0 to show that no forces were acting on the system. From this code, the model was able to predict the position that the pen should be at each given time interval with no forces acting on it. Next, on the graph that I created, the solid red line shows that the model position, which is what V idle did, and the blue dots are the position of the experiment, which Tracker did. My experiment did not fit the model as shown by the dotted blue line. The blue line starts to go below the solid red line, which, as stated before, is the model position. I believe that my experiment did not fit the model due to the fact that as the pen rolls across a table, it will at some time start to slow down. I believe that this is due to the friction that the table had on the pen. Now on to the questions. If I was to change the axis and put it in the negative x direction, the velocity would be negative, but the numbers would remain the same. The graph would show a negative slope that would go in the negative x direction instead of positive. To determine how many total pushes and pulls were acting on the pen is a little bit more difficult to do. If I were to make an educated guess, I would say that there was the force of the table pushing on the pen and the force of gravity pulling on the pen. For the pen to be in constant motion, however, these push and pulls would have to equal 0, like the model showed.